What's up, guys? So I actually just had somebody um, basically submit a request um, for a new series, and obviously I like the idea, so we're going to do a new series. We're going to talk more about genetics. Now, I have talked about genetics previously, whatever, in a few other videos, but I figured I'd try to break it down a little bit more and give more of a wide or a broad spectrum on the subject matter. This is when it comes to balls. Everything else is still, some of it's still weird to me. And even whenever I started ball pythons, I mean, let's be honest, I didn't know it after I learned it the first time. You know, it was kind of like a trial and error type of thing. Eventually, I ended up catching on to the genetics of the ball pythons, and that's where we're at now. So, first and foremost, I don't have every animal that I am going to talk about in the genetics, so I'll just end up putting pictures up here or whatnot. If I mention a morph, I might not put all the pictures of all the morphs. We'll see as it goes. Who knows? Anyways, there is three basic, not so much basic, but there's three genes or types of genes. There's three types of genes, which is recessive, codominant, and dominant. And that's really all you need to know when it comes to ball pythons, at least. Recessive means that it needs two copies. For instance, piebald, right? That's not the only recessive gene, but that's the recessive that we're going to talk about currently. If you have a pied and a normal, they're going to produce normal-looking offspring that are heterozygous or het for that recessive gene. In this case, it would be het pied, a normal-looking animal that is het pied. Typically, even when you have a normal animal that is heterozygous for any other recessive gene, the belly or tracks will be clean, which just typically means that they're not as dirty or as black as a normal. If you look at the belly of a normal, the track scales or belly scales are typically blotches of black all throughout, whereas when you have heterozygous animals or het animals, they are typically clean bellied. With some cases, with some different genes, it's complicated. Some different genes do cause some scaling, coloration on the belly, but we're talking basics. Next, after the recessive, you have codominant. And what codominant is, like this lesser, I'm going to put a lesser right there. That lesser, if I breed that lesser to a normal, I will get 50% of the clutch to be lesser and 50% to be normal. Nothing will be heterozygous because the expression of the gene is visible. If I take a codominant lesser to a codominant lesser and pair them together, I will produce a superform. So if you take the same codominant genes together, you can produce a superform. That is not always what you want to do in instance of the champagne. If you pair a champagne to a champagne, it is known as a lethal combination. The animals don't end up hatching and coming out of the eggs, and even if they do, or you assist them coming out, they end up dead later on, unfortunately. That was something that I ended up learning after the fact that I had planned on that project. Thankfully, I was able to gain that knowledge before I went through with it. That's not saying that it's only with champagnes. That's the only codominant that I can tell you offhand.
but typically you get the super form. So a lesser to lesser, you get a Bell or a Blue-Eyed Lucy, a Blue-Eyed Leucistic, which is a solid white animal with blue eyes. There are several different genes that you can pair to produce that. Either way, it's still two codominant genes. They have to be in the same complex, basically the same structure, whatever. And then you have dominant genes, like pinstripe, for instance. Even though it may be a dominant gene, that does not mean that 100% of your clutch, when paired dominant pinstripe to a normal, does not mean that 100% of your clutch will be pinstripe. I don't know why that is, but it does not ensure that you will have pinstripe in your offspring. Spider is considered a dominant gene only because when paired spider to spider, you have the same risks as champagne to champagne. So I believe the reason why spider is considered a dominant gene is to kind of steer people away from doing that, because it doesn't provide viable offspring. I could be completely mistaken as to why they call spiders dominant. I don't know. That's just my outlook on it. With this series, what we're going to do is, yeah, I just talked about it like this, but I'm going to break it down a little bit more per video. So say my next video, it will be on just one genetic, one type of the genetics, whether it be codominant, recessive, or dominant. And, you know, maybe I can learn more and help spread out that knowledge to you guys as well. Maybe not. Who knows? I hope you guys enjoy this. I hope you guys watched till the end. If you did, please consider at least subscribing to the channel. It's greatly appreciated. We love you. Take care.